Hello, today we are going to see the gravitational field strength. Okay, before seeing the gravitational field strength, we should have a brief introduction on what is the acceleration due to gravity. They are quite the same, but there's small difference. Acceleration due to gravity is a subset of gravitational field strength. Now, we initially stated our Newton's law of motion as Newton's law of gravitation as there exists a force between the there exists a force between two masses where the force is direct proportional to the product of masses and inverse proportional to the distance separating the masses squared. Now, from Newton's law of motion, Newton's second law of motion, we know that the force is equals to or direct proportional to the mass and acceleration, where the constant there is 1. So we are going to use both Newton's law of gravitation and Newton's second law for us to have the gravitational field strength. Now, if I have again a body A and a body B, the body A is going to have a set to force due to body B, that's FB, and this other one is going to cause an equal but also opposite force due to body B. So body A is going to have the force on body B, and all of that is going to depend with respect to their distance they have to each other. How? Now we know that the force of gravitation is giving us g m of A m of B divided by r squared. And we know from the Newton's second law that the force exerted on A, let's say this one is FA and this is FB. The force exerted on A will be equal to the mass of the A times acceleration. Now, we know that this force A is actually equal to this gravitational force because they are exerting between each other. So if I equate, I'm going to have MA times acceleration is equal to GMA MB all over R squared. So I have this and this cancel, so I have acceleration is equal to GMB all over R squared. So we see that the acceleration here is equal to GMB all over R squared. And now this acceleration is going to be called the gravitational field strength. What is the definition of gravitational field strength, or the literal definition of gravitational field strength? It's defined as, from the word, the strength of a field or the intensity of lines that are found inside the field. Fields are capable of being uniform. Our planet Earth has fields, have gravitational field line with magnetic field lines. It has many sorts of fields like gravitational field line, magnetic field lines. Now, the gravitational field line is what pulls us to the ground. And this gravitational field line depends on the distance we have with respect to the surface of the earth, as we are going to prove now. So we need to realize that the force of gravitation is equal to a certain mass, the mass we are, let's say I am a mass. I am that mass times the gravitational field strength G. And now, from this formula, we see that this acceleration is actually gravitational field strength. So G is equal to Gm all over R squared. So the gravitational field strength actually depends at different position on the Earth's surface. So we are going to have certain cases that the gravitational field strength are actually different from each other. with respect to the distance you have from the center of the earth, because the distance r is taken from the center of the earth. So let's see these different cases. So let's starting by case 1, which is the simplest case, will be gravitational field strength at the earth's surface. Let's say I have my planet earth. This is the center of the earth. This is the surface of the earth. From this distance here to distance here, I have the distance separating the center to the surface, and this mean distance given as 6,400 kilometers out of the earth. So from here, the formula of gravitational field strength at the surface of the earth is quite easy, which is gm of the earth, because the mass gm of the earth all over re squared. This is the formula. So how did I have this formula? We initially agreed that gravitational force is giving us gm of a certain surface A times mb all over r squared. In this case, I have the earth and I have my body B. So it will be gm of the earth times the body B all over r separating them, which is re squared. And we also have to know that Fg is equal to m times the gravitational field strength. So another definition of the gravitational field strength is could be defined as the force exerted between two bodies per unit mass. Now, I know that this Fg, in this case, I'm going to involve the mass of this body B. So upon equating them, I'm going to cancel body B and say gravitation of the earth's surface is gm of the earth over re squared. This is case 1. Case 1 equation. Now, case 2. In case 2, it will be above the earth's surface.